All right, it's a derivative, right? So with these derivatives, even if it's implicit, you can still take a second derivative. Ah. That's cool. So we are going to find our second derivative. And how do you get to a second derivative? You find your first derivative first. Good job. And we're going to take the second derivative of x squared plus y squared equals 1. All right? Okay. Look familiar? It should. We just did that in example 1. So let's do it again for just good measure. So to get a second derivative, you got to find your first derivative. So let's do it. 2x plus 2y. And remember, when you take the derivative of y, tack a dy dx on there. Subtract your 2x from both sides. 2y dy dx is equal to a negative 2x. Divide both sides by a 2y. And dy dx is that negative x over y. I just went through that kind of quickly. You can always pause at the video because we've already done it. Now here's the key. You are going to take a second derivative. From here, the notation of the first derivative to the second derivative is this. So for my second derivative, then I'm going to scoot it up just a little bit because I just need to look at the first derivative to get there. So I've got d squared y over dx squared, right? That's my notation. And on the left side, what do we get to do to take this derivative? Pardon me, on the right side, what do we get to do to take this derivative? Quotient rule. Yes, yes. So when we do our quotient rule, we have the derivative of the top, which is negative 1 times the bottom, minus the top, but do you see minus this negative? I'm just going to make that a plus because it's multiplied, right? So we're good. The top times the derivative of the bottom all over the bottom squared. The process is the same. The process is the same. It doesn't matter if you're doing the quotient rule with implicit or not. But let me point something out to you. There will always be a place to plug in dy dx. I already found dy dx. It's my first derivative, right? When you do this, if dy dx equals negative x over y, that means when I have dy dx here, that is equivalent to negative x over y. Good. So plug that in. D squared y over dx squared is equal to negative y plus x times a negative x over y all over y squared. And then what do we have again? Let's write a complex fraction. And how do you get rid of a complex fraction? Yep. Good. We get rid of a complex fraction by multiplying by a common denominator. And here, the only denominator we have is a y. This is over 1, and this is over 1. So, let's do it up. When I multiply through that common denominator, d squared y over dx squared, yes, you have to keep writing that notation because that is what shows that you have a second derivative. So I get negative y squared and then negative x squared, right? So the y times here, the y times this term cancels out, but this x times x, right, is that negative x squared. On the bottom, I end up with a y cubed because I just multiply another one by that one. Okay? All right. Let's try to clean this up a little bit. How about if we factor a negative out of the numerator? D squared y over dx squared. If I have a negative, then I'm going to take x squared plus y squared over this y cubed. Now, ladies and gentlemen, here is the fun and exciting part associated with, let me squeeze this in, implicit differentiation. Look at what we have. Typically, and I'd say the majority of the time, every once in a while it doesn't happen, but it is such a rare occurrence, okay? For us, you are going to look at the original equation to, oh my gosh, you guys, that handwriting is so bad. I can't even do that to you. Let me make this bigger. Sorry. Let's try again. Let's do a different color even. We'll get spicy. Look at the original equation to see if it helps to simplify. And does it? Simplify. There's a Y at the end of that. Yeah, it does. Do you see in this one? Because at the very beginning, we know it's the unit circle, that x squared plus y squared is equal to 1. So if I have an x squared plus y squared, I can replace that with a 1 because you said those are equal from the very beginning. So my actual second derivative here is negative 1 over y cubed. Cool, right? Yes. So a second derivative. All right, a second derivative. I'm going to squeeze this in so we can see the whole thing. When you do a second derivative, you are going to do some substitutions. So here, you will always, no matter what, whenever you do this very first part of the second derivative, you'll have a dy dx that you'll need to sub in for. That's going to happen. Then, most of the time, not every single time, no demand ever, but most of the time when you do a second derivative with implicit, you can simplify it and see what you have from the original. If this equals 1, then you can replace it with a 1. Super cool, right? Yes, I think so too. Woo! That's what we have for implicit. You guys go rock the socks off of practicing this. Practice. And I think you'll see we're just using all of the rules that we've used already. Power rule, chain rule, product rule, quotient rule, and just putting it together here with the two variables. Okay, great job, you guys.